In the last lesson, I explained that strings are lists or arrays of characters. In this lesson, I want to show you a few common ways of using strings in your programs. I'm Hugh, and this is another lesson in my programming course. As I explained in the last lesson, strings are not fundamental data types, by which I mean that whereas the computer hardware knows what an integer or a single character is, it doesn't know what a string is. It's therefore up to each programming language to implement strings, and different languages do that in different ways. Mostly we won't need to know about that because most languages have a handy string data type that takes care of the messy stuff without bothering us with the details. The exception to that rule is the C language, which has no string data type, and in order to use strings you have to work with lists of characters that end with a null character. Now that's hard work, and for now I'm going to stick to talking about strings as they are used in the C# and Java languages. Incidentally, you may wonder where the term string comes from. Its origin is in fact not certain. One theory is that it comes from the days of manual typesetting, when books and newspapers were printed using bits of metal with raised characters with one bit of metal for each character. Characters were strung together one by one to build sentences and paragraphs and eventually whole pages, and the text was printed by stamping out the letters using ink on paper. When a batch of characters had been arranged into a frame, the typesetter would hold them in place by wrapping a string around the letters, hence a string of characters. Now, I'd like to think that's the origin of the term, but in all honesty, well, I really don't know. In any case, you can just think of strings as characters that are strung together to make words, the way that pearls are strung together to make a necklace. Anyway, now back to this lesson. The two languages I'll be using in this lesson, C# and Java, are both object-oriented. In those languages, an object is a sort of package that wraps up some data and some behavior. In a string object, the data is the list of characters that form the string. The behavior is the code, the functions or methods that can be used to manipulate those characters. Now, if you've never come across object orientation before, don't panic. I'll explain it in detail later in the course. One of the most common things programmers need to do with strings is to stick one string onto the end of another one. If I have two strings, hello and world, I can append world to the end of hello and create a new string, hello world. In Java, C# and many other languages, this sort of string concatenation can be done using the plus operator. Here in Java, I assign the string hello world to a variable named greeting, and I display the result when I run the program. And this is the C# version, which, as you can see, is very similar. Another common thing I may want to do is find a character in a string. The characters in strings are, in most languages, indexed from 0. So the first character has the index 0, not index 1. The second character has index 1. The last character is at the index given by the length of the string, -1. So if the string contains 5 characters, the last character is at index 5 -1, that is at index 4. In many languages, you can index into a string by putting a number between square brackets after the name of a string variable, like this. Now, that's in C#, but Java has a different way of doing the same thing. It uses the char_at method to get a character at an index, like this. If I want to get the last character, I need to find the length of the string and subtract 1 from it. That's because strings are 0 indexed. Think of a string with 1 character, its length is 1, but the index of the last character, in this case the only character, is 0. A string with 2 characters has a length of 2, but the index of the last character is 1. To find the string length in Java, I use the length method, then simply subtract 1 to get the last character. C# can also give us the length of a string, though the syntax is a little bit different. Now, what if we want to process all the characters in a string, say to print each character on a separate line? We can use a loop to do that. This loop iterates over, that is, it counts through the characters in the string one at a time. And this bit of code displays each character followed by a new line. Incidentally, note that I'm using Java's print method rather than println, and C#'s write method rather than writeLine. That's because println and writeLine automatically add a new line after displaying a string. But for the sake of this example, I specifically don't want that to happen because I want to prove that \n adds a new line. Don't worry about how these loops work. I'll have more to say on that in another lesson. All you need to know is that this code splits the string into its individual characters one by one, then assigns each character to this loop variable C. And then this code displays that character followed by a line break. Most object-oriented languages come with lots of named routines or methods to help you work with strings. For example, this is the toUpper method in C# and the toUppercase method in Java. Or there's also the toLower method in C# and the toLowercase method in Java. Bear in mind that strings don't have to contain any characters at all. In other words, a string can be empty, like this. An empty string has a length of 0. Strings can also contain special characters, non-printing characters. We've seen one special character already, the new line character \n. I enter \n in order to add an invisible new line character, and that displays a line break on screen just as though I'd pressed the enter key. In the next lesson, I'll show you a few more special characters that can be put into strings. Be sure to click subscribe and click the little bell icon to be notified whenever I upload a new lesson.